Hey everybody, welcome back. Today we're going to be going over an introduction to C Sharp. For that we're going to be building a console app that keeps track of pets. Pets are a cause that are near and dear to my heart, so I figured we'd just as well use that. So here we are in Visual Studio right where we left off, or Visual Studio Code right where we left off. I'm going to close this. If you hit Control tilde, it will bring up your terminal. Alright, so we have an empty directory, there's no code here. The first thing we're going to do is initialize our Git repository with Git init. All right, now we have a .git folder to keep track of all of our source control. All right, so the first thing we need to do is to create a solution in .NET and C Sharp. Our projects are split into solutions and projects. A solution owns one or more project. So to start with, we need a solution. So for that, we're going to do .NET new list, and that's going to list out all of the templates that we have installed with .NET. So you see they have a short name, what language it supports, some tags, and a template name. Now we're looking for a solution. They're in alphabetical order, so it's towards the bottom. Solution file, short name is SLN or solution. So we're going to just do .NET new SLN -n, because we're going to give it a name. That's what the N stands for. Microblogger. The template solution file is created successfully. All right, so if we hit ls, we now have our microblogger.sln. And if we go to our Explorer over here, we see it here in our Visual Studio Code as well. We can open that up, and there's not really anything of any real consequence in here. I never look in the solution file, but it does exist, and it is something you can look at. All right, so now what do we want? We want a console app. So if we do .NET new list again, console, so up here, and here it is, console app, short named console. So we'll do .NET new console, and then we'll do a -o because we're going to output it. And we're going to output it into the directory microblogger.introduction. All right, then if we hit ls, you see we have microblogger.introduction in here. You can also see it over here. However, we're not done yet. Like I said earlier, a solution owns one or more projects, so we need to give ownership of our project to the solution. Doing so is very easy. It's just .NET SLN for solution, add, because we're going to add a project to this solution, microblogger.introduction, which is just the directory that contains our project. Project added to the solution. Great. So now I'm going to close Visual Studio Code and reopen it. And the reason for that is it didn't know that we had a solution yet. But you see down here in the bottom left, we have our Solution Explorer. So I'm going to collapse Microblogger and expand Solution Explorer. All right. So what do we have in our console app? It's inside of this microblogger.introduction, and all we have is this program.cs. And it's just a single line of code, the console.writeLine hello world. That seems like a good place as any to start, so we'll just cd into our microblogger.introduction, and we'll do a .NET run. And that's how you run an app in .NET. You just go into its directory and .NET run. And you see it output hello world to the terminal, which is exactly what you'd expect. If we wanted to change what this says, just in between these double quotes, we're going to say, hey there world, exclamation mark. And then we're going to do a .NET run again. And it says, hey there world. So, great. This line above is a comment. If you don't know what a comment is, it's just additional information for the developer. It allows us to communicate information that is ignored by the machine. So we can write whatever we want here. Anything goes here. And when this is compiled down into a program, these two lines are going to be deleted and you're going to be left with just this. That's not exactly how it works, but that's a simplified overview. All right, so we want to be able to track and manage pets. We have a couple of ways we could do that. We're going to just comment out this console.writeLine. We don't need it. So we could, if we wanted to keep track of a pet's name, say string pet name is equal to Bailey. right? This is one of my dog's names, is Bailey. So we have this variable called pet name. If we hover over it, you can see it's a local variable and it's a string and it's called pet name. All right. So now you notice this is surrounded in double quotes. This was surrounded in double quotes. They're both strings. So we can do console.writeLine pet name, and we'll run that, and it outputs Bailey. Okay. So now we want string pet species. She's a dog. And then we want int. An integer is just a number that contains no decimal places. Int age equals 16. So we want to output Bailey's name, her species, and her age. So what we can do is this: pet name plus is a plus pet species plus and is plus age plus years old. Right? So then we can run this, and we're expecting Bailey is a dog and is 16 years old. And that's exactly what we get. All right. However, there is a much better way to do this, because you can see here, this is kind of hard to read. Imagine if we had like 5 of these variables instead of 3. It would get a lot more difficult to read with all these string concatenations with these plus signs and all that, so we'll just comment that out. What we're going to use instead is it's called string interpolation. And what that means is we are going to build our string with a $sign here. That's how we tell C# that we're going to use string interpolation. And then double quotes. Every line in C# must end with a semicolon. Well, every statement in C# must end in a semicolon. So what we can do here is inside of curly braces, we can say pet name, and that's going to refer to this pet name up here. If we hover over it, it says local variable string pet name, local variable string pet name. They are the same thing. Is a pet species and is age years old. You can see this is much shorter, and it's also a lot easier to read. .NET run, and we get the same output. Okay, so we have information about my dog Bailey. Now we want to also have the same information about my cat Tiny Cat. String cat name is Tiny Cat. String pet species, no. Cat species is equal to cat. And int cat age is 11. All right, now we want to output all of the same information, but this time about Tiny Cat. So we're just going to copy and paste that, and we're going to change this to cat age. We're going to change this to cat name. All right, now let's run this. .NET run. Tiny Cat is a dog and is 11 years old. Well, that's not right. That's because we didn't replace pet species with cat species here. So if we replace that and run it, we see Tiny Cat is a cat and is 11 years old. All right, so the reason that we had that little mistake is because we were copying and pasting code around, and that's usually an indication that there is a better way to do things. So you can see we're declaring the same variables a lot, like a name, a species, and an age. What we can do is we can write a class. A class is a group of related data and methods that all belong together. And so you can see here we've got the same pieces of information about our pets. We've got a name, species, and age. So we could create a class that represents that. So let's go ahead and do that. Public class, and we're just going to call it pet. And we'll save that. All right, so what do we need? We need a string name. We need a string species. And we need an int age. Right, and we're not calling it pet name or pet species or pet age because it all belongs to the pet class, so the pet is kind of implied. All right, so we want to create a new pet. Let's comment out all of this code. That's how you do a multi-line comment in C#. You start it with /star and end it with */. All right, so we want to create a new pet. Pet equals new pet. And this is how you do, well, here, let's do this. It's a little bit more clear. This is how you would initialize an object in C#. You would call the constructor first with these parentheses, which aren't strictly necessary. This works as well, but it's a little more clear if you include the parentheses to start. And then we can assign any of these fields down here. So we would say name is equal to Bailey, species is dog, and age is 16. All right, so for some reason, we're getting errors. This is part of what we get from that C# dev kit we installed in the previous video. So we have an error that says pet.name is inaccessible due to its protection level. So by default, when we declare these things, they are private. And what that means is nobody from outside of this pet class can reach in to this and make any changes or even read this data by default. So what can we do to make it so it's accessible? Well, we can just slap public at the start of all of these. Oops. Public. And you see here, now our errors have all gone away. Great. However, this still isn't quite what we should be doing. Let's start with how we declared our fields here. So in C#, when you are creating a public-facing field or property, it should start with an uppercase letter. It doesn't have to, but it should. So we'll just replace those and replace these. Great. So that's one thing out of the way. Now, what else do we need to do here? Well, first, let's do another console.writeLine, right? And we're going to use string interpolation again. Pet.name is a pet.species and is pet.age years old. All right, let's run it. Bailey is a dog and is 16 years old. We will fix these warnings momentarily. All right, so now let's create another pet record for Tiny Cat. Pet Tiny Cat is new pet. And I'm going to show you again, we can leave off those parentheses. Name is Tiny Cat. Age is 11. And we're going to copy this, paste it down here, and replace it with Tiny Cat. Tiny Cat is a blank and is 11 years old. Well, as you can see here, we forgot to assign Tiny Cat's species to cat. So let's go ahead and fix that. Species equals cat. And we'll run it again. Tiny Cat is a cat and is 11 years old. Okay, great. So what problems do we still have? Well, we saw that we could leave off some crucial information like the species. And right now we only have 3 fields in here, but what if we had 5, 10, 15, 50, right? It would be really difficult to remember what fields are important, what fields are required, and what fields are optional. So what we can do is we can add a constructor to our class. Right now, we do have a constructor. That's why we can put these empty parentheses here, is because we have a constructor. And what this constructor looks like is this. Public pet. And then it just doesn't do anything. You can see here, it tells us we have 2 references to it. Tiny cat equals new pet, and pet equals new pet. So we are using this constructor twice, right here and right here. But it doesn't do anything. Well, we want to require the name, the species, and the age. So inside of the constructor's parameters, we're just going to say string name, string species, and int age, because we're requiring all of these things. And then we just say name equals name, species species is species, and age is age. All right, now we're going to have a couple of errors up here because we're using object initialization here, and instead we need to be using our constructor. So the name is Bailey, the species is dog, and the age is 16. And then here for tiny cat, we need to say tiny cat is equal to new pet, named tiny cat, cat 11. Okay, so let's run it. Excellent, so we get the output we were expecting, and we don't have these warnings. Why don't we have these warnings? Well, it's because we have a constructor here, and inside of this constructor, whereas previously we had a constructor that did nothing. Now we have a constructor that assigns the name, species, and age fields, and that's what these warnings were about, is that we didn't say the name or species were optional, but it didn't have a value after we left our constructor. All right, great. So now, oops, we can get rid of that. I don't know where that came from. Now we have this, oops. We have this requirement. We want to tinycat.species equals fish. Right? So what do you think is going to happen with our third output? Tiny cat is a fish and is 11 years old. All right, so we don't want our pets to change species. Really, we don't want any of our information about our pet to change, except for in very specific circumstances. But we would never want them to be able to change the species. Okay, cool. Let's just change this back to private. Well, now we have a problem, because we can't read a private variable. So let's change it back to public. But now we have the problem that we can still assign species. So what we're going to do is right now this is a field. If you hover over it, it says field string pet species. We want to turn it into a property. So if you come from Java, you would probably do something like this. Public string get species, return species, public, and then you wouldn't have a setter because we don't want to set anything. And that's all well and good, right? We could put this back to private, and we could say get species. I am not sure if I'm spelling that right, to be honest. Get species. And then you see we can read the species, but we can no longer set it. So cool. That works. All right. However, in C#, we have some better ways to do things. So what we can do is instead of writing getters and setters manually, we can just get rid of the semicolon and say get semicolon set. And we're going to do that for all of our fields. We're going to turn them into what are called properties. And then we're going to just turn this back into species. All right. So what does that give us? Well, right now we can still say tinycat.species is equal to fish, right? And nothing's going to stop us from doing that. Tinycat is a fish and is 11 years old. That's still wrong. We still don't want that. So what we can do is we can make it so this getter here is public, so anybody can get the name, anybody can get the species, and anybody can get the age. But we're going to turn the private set it, or the setter private. There we go. And the reason we're doing that is now, you see here, tinycat.species equals fish, we're getting an error here. And the reason for that is our setter is private. So nobody outside of the pet class can actually change the species. And if we hover over here, the property or indexer pet.species cannot be used in this context because the set accessor is inaccessible. So that's just a long way of saying this is private and you can't use it. So great, that's that requirement done. We can no longer change a pet's species, name, or age. However, a pet's age does change over time, right? They have birthdays and they age up. So we're going to say tiny cat just had a birthday. Tinycat.age is equal to tinycat.age plus 1. All right, we still have a problem here. The property or index or pet.age cannot be used in this. This is the same error as before. It's because we have a private setter. Well, that's easy enough. We can just get rid of the private here. So now we can do that. And we can copy this again. And we're going to run it. And now tinycat is 12 years old. All right, that's great. But now I could have, instead of done +1, I could have done +11 on accident. .NET run. Oh, he's 22 years old. That's not right. Well, I could have also subtracted 1 instead of adding 1. He went from 11 years old to 10 years old. That's not right. So we're going to put this private back because, as you can see, we can't necessarily trust the people outside of this class to directly write to the age. Instead, we're going to create a function here. We're going to call it public void, and void just means we're not returning anything from here. And we're going to call it have birthday. And what do we want to do when we have a birthday? Well, we just want to say age plus plus. And what this does is it gets the value of age, and then it adds 1 to it. And that's it. So what we can do here, instead of changing the age directly, we just say tinycat.have birthday. And then we .NET run that. Tinycat is a cat and is 11 years old. Tinycat is a cat and is 12 years old. Sweet. So we have this behavior that sets the age to age plus 1. And all of this is all private. Okay, cool. Well, now we have the stringification here, and we're repeating a lot of code here, and we don't want that. There's a principle called DRY. It stands for don't repeat yourself. So we want to be able to output all of the information about our pet consistently and easily. So let's try something. We're just going to comment out this, and this. And we're going to try just console.writeLine tinycat. Let's see what we get. We get pet. Okay, so we know it's a pet, but that doesn't have any of tinycat's information, right? So if we had done a console.writeLine pet, let's run that. Pet. Okay, these are different pets, but they're outputting the same value to the console. So what we want to do is every class, by default, has a toString method, and what that means is when we try to use the pet as a string, it's going to call that toString method. And by default, it's not very smart. It just outputs the name of the class. But we can do what's called method overriding. So if we go down here and we say override space toString and hit enter here, you see here we now have public override string toString. And what we need to do is we need to return a string from this method. So we're going to just copy this, and we're going to return it. And instead of tinycat.age, it's just age. And instead of tinycat.species, it's species. And instead of tinycat.name, it's just name. Right? So let's run that. Tinycat is a cat and is 12 years old. Bailey is a dog and is 16 years old. So great. That's that. All right. Now we have another requirement. We want to be able to tell if two pets that belong to the same person, so this pet list is just one person's pets, and we want to be able to tell if they are the same pet or not. So let's see here. Pet 2 is new pet Bailey dog 16.
All right, so what do you think? If we compare pet and pet2, do you think they're going to be the same? Well, let's just console.writeLine pet.equals pet2. So, what are you expecting? Do you think this will be true or false? Because it will be one of those. And the reason for that is if you hover over equals, it's returning a Boolean. And Boolean is always true or false. So let's run it. It's false. But all of the values for this pet are the same. They have the same name, the same species, and the same age. And since they belong to the same person, me, then we should probably assume that they are the same pet. It would be really weird if I had two pets with the same name that were the same age and had the same species. So, what can we do here? Well, just like we overrode toString, we can override equals. And the syntax here is a little bit weird because you see here we're not taking in a pet, we're taking in an optional, that's what this question mark means, an optional object. So it could be of any type. It could be a number, it could be a meal, it could be a post in our database, or it could be another pet. So we need to check that. So we can say if obj is pet. So this just checks to see if object is of type pet, other pet. And this stores it in a variable called other pet if it is a pet. Then we can return other pet.name equals name and other pet.age equal to age and other pet.species is equal to species. So we're going to return that. This will be true if all three of those conditions are true, but false if any of them are different. And then by default, we're just going to return false because if it's not a pet, it's not going to be the same pet because it's not a pet. All right, so let's run this. And we get true. All right, that's great. We have written a decent amount of code here. This goes from line 34 down to line 65, so 31 lines of code, just to represent our pet class. We can do better. So we're going to just comment out this whole class. And I'm going to show you how we can do all of that and a little bit more with just a couple lines of code. And we're going to use what is called a record. Public record instead of a class. And we're going to call it pet. And it's going to take in a string name and a string species, right? Then we're going to create our semicolon here, or our curly braces, and we need to give it a constructor that also takes in the age. Well, first we need to create the age field. Public int age get private set, right? Because we want to be able to change the age still, so we need a getter and setter for it. Then we're going to create a constructor. Public pet string name string species int age. And that's going to call this other constructor that we have up here because that's what this is it's a primary constructor. So we're going to call that with name and species. And then inside of this constructor, the last thing we want to do is set age equal to age. All right, so far we have 8 lines of code and we're almost done. We just need to have our public void have birthday. Age plus plus. All right, now we're done. It goes from line 34 to 47, so 13 lines of code. That's like a third of the code right there. And everything still compiles, no red squigglies. So let's see what we've got. .NET Run. We get true for this, where we're checking pet.equals pet2. All right, let's write out tiny cat and pet. All right, so see, we have pretty printing as well. So we see the name is tiny cat, the species equals cat, and the age equals 12 because we had our birthday. So everything is working at this point. There is really just one more thing I want to show you. So up here, we are doing pet equals new pet. and pet2 equals new pet. That's a lot of pet. What we can do is instead of saying pet, we can say var, right? So let's hover over pet2. You can see it's a local variable. It's of type pet, and it's named pet2. Well, what do you think the type for pet is going to be? Let's hover over it. Local variable pet, pet. So it's the same type, which is great. We can just use var. So this is a feature, it's called type inference. And what that means is the compiler knows what type this is going to be, right? Like if it knows that this is a pet, because if we tried to assign the number 2 to it, it would say we can't convert from integer to pet. So it knows what the right-hand side of this equal sign is. So we can tell it, hey, you figure out the type. Var pet equals new pet. Now what you might be thinking is, okay, now since we didn't declare the type, we might be able to assign a number to it. So let's try that. That equals 2. Not implicitly convert type int to pet. So it still knows that this is supposed to be a pet. And it knows that this is not a pet. So we can just use var everywhere. Now, I'll admit, using var does not necessarily save us a lot of typing here. However, I'll show you an example. We could have dictionary int list string my cache is equal to new dictionary int list string. All right. See, now this is a lot of typing. We repeated dictionary int list string twice. And we can make that a lot shorter by just saying var. And if we hover over my cache, it's still a dictionary int list string. Great. So that is type inference. And that is the end of our introduction to C#. So we want to do one thing, right? Because I showed you, or I had you create a Git repository. Now we're going to commit to it. But before we commit to it, we're going to run one more .NET command. .NET, or first we're going to go up one directory. Then we're going to run .NET new git ignore. And what that does is it creates a git ignore file, which will have all of our binary files and stuff like that excluded from Git, because you don't want to include binary files in Git. You only want your source code. So .NET new git ignore. And you see over here, we went from having like 27. Here, I'll show you. Yeah, we have 27 changes in our source control right now. Then if we do .NET new git ignore, watch it change down to 4. So if we click here, we have a git ignore, we have a microblogger.sln, we have our project file, and we have our program.cs. So we're going to just write our commit message. End of video 2. And we're going to hit commit. Save all and commit changes. All right. And with that, we have our introduction to C# is complete. And we have it in our Git repository, and we are good to go. Thanks for watching, and I will catch you in the next one where we talk about Web API basics, and we actually create our Web API project and get it up and running. All right. See ya.